Hello, Matt Davis here with more homework quiz help. This one comes from section 9.3. Suppose that we are testing the claims H0 is that mu equals 6.4, H1 is that mu is less than 6.4, and our sample produces an X bar of 6.13, an S of 1.2783, and is a sample size of 15. Calculate the value of our test stat and round the answer using 3 decimal places. People had a little bit of trouble with both the test stat and the p-value, so I'll do both of those here. And then we'll also talk about steps 1 and 2 just to help us get set up. But first, let's make some changes in the interest of giving help rather than answers. And we're just going to make one change here. So instead of having an X bar of 6.13, we're going to work with an X bar of 6.17. So that'll change the answers, but the work will still match up. So test stat, which is what they want us to find, is step 3. But step 1 would be to write the null and alternative hypothesis. Those are already done. Step 2 would be to write down alpha, and we don't have that here, but we don't need it for step 3 or 4 anyway. So let's get into the step 3, which is the test stat. First thing should be to write down the formula. First part about that is figuring out, are you in mean land or proportion land? We have an HO that is a claim about a mean, mu equals. So we are in mean land. So because of that, we're going to use a t-score. Not satisfied with that t. Let's go back and try that again. All right, a t-score, which would be x bar minus the claimed mean divided by s divided by the square root of n. All right, in terms of pieces, we need x bar right here. We need the claimed mean right there in HO. We need S given to us, and we need the sample size given to us. So all the pieces we need are given, so we can just jump right in there and start calculating. X bar would be 6.17 minus the claimed mean, which comes from H0, so that would be the 6.4, divided by S, which is 1.2783, divided by the square root of the sample size, which is 15. So that's what we need, and we'll go to the calculator and get that. So when we're back from the calculator screen, we'll have our t is approximately equal. Before we head out, I will point out that even though the way the test statistic is written is fine, one of the things you need to remember when you go to the calculator is parentheses around the top and parentheses around the bottom. So we'll make sure we do that as we hop over there. So start out with those open parentheses for the numerator. The x bar, 6.17, minus the claimed mean of 6.4, divided by, and then open parentheses because we need parentheses around the denominator as well. So 1.2783 divided by the square root of the sample size, which was 15. The first end parentheses I do is ending the square root. The second one will end the denominator. So we have parentheses around the top, parentheses around the bottom, and we would round our test stat to 3 decimal places, so negative 0.697, rounding that 6 in the third decimal place up because of the 8 that follows it. So switching back over, we have negative 0.697. So this particular question was asking for our test stat, so there it is. That's the part we would put into active learning for this particular question. But again, some students struggled with the p-value as well, so let's take a look at that in this one too. So I'll start out drawing a bell-shaped curve. This particular bell-shaped curve is not going to be a z-curve though, it'll be a t-curve because our test statistic is a t-score. And when you're dealing with a t-curve, you need a df. The df is the sample size minus 1. So in this case, that would be a df of 14. We put a 0 in the middle representing the claimed mean, and then we put our test statistic on, negative 0.697. And then when we go to shade, we have to look at our alternative hypothesis, which said less than 6.4. Because that's a less than, we're going to shade to the left side. We did not shade to the left side because our test statistic landed on the left side. We shaded the left side because we were working with a left-tailed test due to the less than in H1. So whatever that area is over here on the left, because it's a left-tailed test, that will be the p-value. So our p-value is the area. For a t-curve, we'll use TCDF. Our left-hand boundary is all the way forever to the left, so negative infinity. Our right-hand boundary is right here, negative 0.697, and then we need 697. And then we need to squeeze in our df also, which would be 14. And then we can go to the calculator, and whatever we get right there will be our p-value. All right, so calculating that t-score, we're going to start off in the distribution menu. Since it's a t-score, we'll be working with TCDF. Our left boundary was negative infinity, so we'll hit negative alpha I, with the infinity being stored into the I. Then our t-score, so negative 0.697, and then followed by the degrees of freedom, which was 14. And then p-values get rounded to 4 decimal places, so 0.2486, and keeping the 6 because the digit that follows is a 0. So p-value was 0.2486. So that would be our answer for the next question about p-value. And then we could go on and make a decision about rejecting, not rejecting, and so on. But this is the two steps right here that people had the most trouble with, was the test statistic and the p-value. So then thinking about some spots where that goes wrong for people, forgetting parentheses around the top, always a concern. When you move from the z-scores to the t-scores, we have this new concern of making sure you put parentheses around the denominator also, so you want to be careful with that. Whenever you're dealing with an area to the left, sometimes people forget to put the negative on their infinity, or they forget to put the negative infinity as the left boundary. So make sure you're doing those in order. Make sure that the area you get kind of matches your pictures, so we have a decent chunk of the left-hand side, and so getting an area around a quarter makes sense. Make sure you've calculated the df rather than using the sample size. Don't double it because it's not a two-tailed test, and that's coming from H1, which had a less than. All right, I hope somewhere in there you saw where it went wrong for you and you're ready to head back. Good luck to you as you go back to the quiz.